Welcome to The Explainer. Today, we're jumping into a massive challenge. You've got these incredible AI systems that are designed to be creative, to be, well, unpredictable. So how in the world do you control that? We're going to break down the quality control loop that modern platforms are using to tame these wild AIs and make them actually trustworthy for the real world.
Okay, so this really nails the core problem. Think about old school software, right? It's like a calculator. You put in 2 plus 2, you always get 4. It's predictable, it's deterministic, easy to test. But generative AI, it's a whole different beast. You give it the same prompt twice, and you might get 2 completely different, perfectly valid answers. That creativity is what makes it so powerful, but it just completely shatters our old way of testing things with a simple pass or fail. So what do you do?
All right, so here's how we're going to tackle this. We're going to walk through the solution, which is basically a super powerful feedback loop. First, we'll dig into the challenge itself. Then we'll talk about observability. Think of it as our mission control. After that, we'll decode the AI's mind, turn that into a report card, and finally, automate the whole thing with the quality gate. Let's get into it.
Right, so our first stop, the AI quality challenge. We've got to figure out how to move beyond those simple pass-fail tests for these systems that are, by their very nature, unpredictable.
So where do we start? We start high up with what you could call mission control. It's all about AI observability, getting that 30,000-foot view of your entire fleet of AI systems. Imagine a central dashboard, a control plane, where you can see everything that's happening at a glance. And on that dashboard, you're looking at the vital signs of your AI. Things like success rate, how fast it's responding, that's latency, how many tokens it's using, and really importantly, what it's costing you. This is your early warning system. It's the first line of defense that lets you know, hey, something might be off here.
Okay, so your dashboard is flashing a red light. Maybe latency is spiking. You know what happened, but you have no idea why. To figure that out, you've got to zoom in. You have to decode the AI's mind, and this is where a super important concept called tracing comes into play.
So what is tracing? Honestly, the best analogy is a flight data recorder for your AI. It captures everything, every single step the AI took in its thought process to get to an answer. It uses this open standard, OpenTelemetry, to log the whole sequence, every tool it decided to use, every function it called. That black box of AI decision-making, tracing cracks it wide open. It becomes an open book.
And here's how that data actually flows. Your AI agent does something. OpenTelemetry is there, capturing the entire play-by-play. Then all that rich data, that telemetry, gets piped into a service like Azure Monitor. And this is where it gets really cool for developers. They can jump into tools like Application Insights or run queries in Log Analytics and literally visualize the entire chain of events. They can pinpoint the exact step where something went wrong or which specific function call is slowing everything down. It transforms a total mystery into a solvable, debuggable problem.
All right, so now we can see everything. But seeing the steps isn't the same as knowing if the final answer was actually any good. All that raw data from tracing is fantastic, but it doesn't give you a grade. We need to go from traces to, well, report cards. We need a way to score this thing.
Which leads us to this, the million-dollar question, right? Now that we can see every little thing the AI does, how do we actually grade it? How do we evaluate something that's supposed to be creative? It feels right, just doesn't cut it. We need hard, objective data.
And the answer is to use a completely new kind of report card, with metrics built just for AI. On the quality side, you're looking at things like intent resolution. I mean, did the AI even understand what you asked it to do? And groundedness. This is a big one. Is its answer actually based on the facts you gave it, or is it just making stuff up, what we call hallucinating? And then there's the whole risk and safety side. You're actively testing it. Can it be tricked by a prompt injection attack? Is it going to spit out dangerous code? These are the new tests.
So, what you're seeing is a process called continuous evaluation. And this is the magic trick, really. It's the engine that takes a fuzzy, subjective idea like a good answer and turns it into a hard, objective score, a number you can actually track and improve.
Now for the final piece of the puzzle, and honestly, this might be the most powerful part. We're going to talk about the automated quality gate. This is where we take all of this evaluation and plug it directly into the CI/CD pipeline, right into the developer's workflow.
And that's because, as this says, integrating these checks right into the development pipeline, well, that's what makes AI truly enterprise-ready. This isn't just about watching a system that's already running in production. No, this is about building quality and safety in from the very start, from the moment a developer writes code,
by making it part of that CI/CD process.
So check out this loop. It's a completely automated quality gate. A developer pushes a change to the AI. Immediately, the CI/CD pipeline just kicks off. It automatically runs all those evaluations we talked about, checking the new version against the benchmarks for performance, for safety, for quality. And here's the kicker. If the scores drop, if it gets worse in any way, the pipeline stops, dead in its tracks. It's a go, no-go decision, an automated guard that ensures a bad update never makes it out to your users.
And there you have it, the whole loop altogether. You observe the system's health, you trace to understand the why, you evaluate the performance with objective scores, and you only deploy when it passes the automated gate. This feedback loop is everything. It's what allows teams to build and improve AI systems with real confidence. This isn't just a neat idea. This is the new paradigm for building AI you can actually trust.
So that leaves us with one last kind of mind-bending question to think about. If AI systems can be automatically evaluated and improved, what's next? As these systems get better and better at checking their own work, where do we go from here? I mean, what happens when an AI can not only be graded, but can start to automatically fix its own mistakes? Now that is the next frontier.